Good day. Today we'll be focusing on calculus. So we are going to start straight in first principle, where I'll be introducing calculus. So let's say you are given a graph that is like this. Let's say you are given a graph f of x. Let's name our graph f of x. So let's say the distance from the origin, which is 0, up to here is x. And the distance from the origin up to here is what? Is a. That means our y values will be what? Go straight. We touch here. Go straight, go straight, go straight. That means our y value here is what? F of a. Then our y value here will be what? F of x. So, from previous grades, you were taught that when you are calculating the gradient, you know that the gradient of a straight line is calculated by y2 minus y1 over x2 minus x1. So, from this formula, you know that the gradient of a straight line is what? Is constant at all the points. So, in this case, let's say you have a line that is like this. You have a straight line. So, when they say calculate the gradient of this straight line, you are going to say y2 minus y1. Let's say our y2 is f of x. You are going to say m is equal to f of x minus f of a, which is y2, y1. Then our x2 is what? Is this one minus our x1, which is a. So this will be your formula for your gradient of this straight line. But then in calculus, we are looking specifically at a curve, at curves. So when we want the gradient, we want to know the gradient of a curve at any point. So we know that the gradient of a curve is not constant. The only gradient that is constant is for a straight line. So in this case, you know that the gradient of a curve differs according to the point. So in this case, you want to know the gradient of this curve at which point? Let's say at this point where I labeled a and x here, x and f of a, f of x. At this point, let's say we are looking for the gradient at that point. So calculus says to make our lives easier and to make this thing understandable, let's say the distance from this x up to here is h. That means our x value here is what? X plus h. Then our y value will be what? F of x plus h. So in this case, we now see. So we are saying we want to calculate the gradient at this point, x and f of x. We want to calculate the gradient. So when calculating the gradient at this point, we are going to do what? We are going to draw our straight lines. Remember, the gradient at this point is equal to the gradient of a tangent that passes at this point of the tangent of this graph at this point. Not at that passes, but at this point. You understand what I mean? That means the tangent that touches this graph only at this point. So what we are going to do, we are going to draw straight lines. Our first straight line is the one that touches these 2 points. Then we reduce the distance, we reduce the distance. Then we can see that these lines are becoming a tangent. So what is happening when we reduce the distance? Remember, what is our distance? It's h. So we are busy reducing what? The length of h. So we want to know what is happening when we are reducing the length of h. That's our concept. So we can see that h is approaching 0. Remember, h is a number. but then you are busy reducing it bit by bit. That means it is approaching zero. It is going to reach what? Zero, but it can't be negative since, well, h starts here after x. So remember, when it arrives at x, it's gonna stop. So in this case, we are going to learn about f prime x. This is what they use to represent what? The gradient, the slope. You can say the slope. You can say the first derivative. Yeah. You can also say different types of ways. They can say differentiate. So those are the types of questions they can say. So in this case, they are going to say differentiate this equation from first principle. That means they want the equation of the gradient, of calculating the gradient. So let's say they are saying differentiate f of x is equal to 2x plus 3 from first principle. Immediately you hear the word from first principle, you think of what? Of the formula. The formula that I was explaining there simply means f prime x will be what? The limit as h approaches 0. Remember, our h is busy approaching what? 0. Of what? Remember, now, in this case, this is our y2. This is our y1. That means this is our x2. This is our x1. In this case, we are going to have what? F of x plus h minus f of x. Then our x2 is what? Is x plus h minus our x1 is x. So that means our formula is what? Limit as h approaches 0. That means we are reducing the distance of what? Of f of x plus h minus f of x. All over what? X cancels x, we have what? H. So we can see this equation. What is the meaning of this equation? So this equation, that's what we use for first principle. So when talking in terms of limits, what do you have to know? So limits, we have loss in limits. We have loss. But you as a grade 12 student, what you must know about limits are only two few things. So in limits, before you substitute, always before you substitute, remember, in this formula, in this case, you are going to substitute what? 0. We see what? H, because h is approaching 0. So in limits, the law says before you substitute, what you must do? Factorize or simplify first. So you must simplify and factorize where possible. If you understand, before you can substitute. You only substitute when you can't simplify your equation further, or when you can't factorize, or there's nothing that cancels. For example, let me just do example. Let's say they're saying the limit, calculate the limit as x approaches 2 of what? Of x squared minus 4 over x minus 2. So we can see that if we start by substituting, we are going to have 2 squared minus 4, which is 4 over 2 minus 2, which is 0 over 0. 0 over 0 is what? Is undefined. Why? We know that a number divided by 0 is what? Is undefined from maths. But 0 divided by a number is what? Is 0. So these two things are two different things you must take note of. So in this case, this equation is not undefined. But then because we don't follow the limit laws, we get an undefined solution. So now let's follow what I've just said above. I said we do what? we factorize and we simplify where possible. So let's start by factorizing. X squared minus 4. Can we factorize it? Yes, it's going to be what? Remember, as long as you haven't substituted what x is approaching, you continue writing the limit as x approaches. So it's limit as x approaches to of what? Factorize x minus 2, x plus 2, all over x minus 2. So this cancels this. And remember, we are not done. We are still copying the limit as x approaches 2. What is left? X plus 2. So since now we substitute, we can't simplify, we can't factorize further. So now we substitute. That's when we can substitute. We are going to write what? 2 where we see x. Now since we are going to write 2 where we see x, we don't have to write the limit. We are going to say what? 2 plus 2, which is what? 4. That's how limit laws works. So even in this formula of first principle, you can see that if you substitute 0 where we see h, we write 0. That means you are going to have an undefined solution, since well our denominator cannot be 0. Remember, at the top we have our what? Numerator. At the bottom we have our what? Denominator. So you must know what I mean when I'm saying denominator and when I'm saying numerator. So let's make an example. Remember, I said f prime x, which is the slope, which is the derivative, the first derivative. So I said that means the gradient, that is the gradient of a curve at any point. So in this case, let's say we are given the straight line y